Most students lose incredibly easy marks on section 16.1 homologous pairs of chromosomes. It happens all the time. But right now, I'm going to expose the one tiny mistake that's probably costing you marks before you even realize you've made it. If you're sitting your Cambridge International AS and A-level biology exams, this explainer is going to show you exactly what examiners are looking for behind the scenes and how to stop leaking those precious points when you're under pressure. Okay, let's dive right into this. This is the exact cold open mistake where ordinary, everyday revision totally fails you. Imagine you're looking at an exam question about homologous chromosomes. You spot a shared trait, you write it down, and you move on feeling pretty good, right? Well, just like that, your grade boundary drops. Why? Because you miss the critical differences and the explicit comparative connectives that the examiner strictly demands. Finding just a single similarity? Yeah, that's literally never enough. So, let's formally kick things off with Section 1, Core Concepts and Examiner Warnings. To stop losing these marks, we really need to look at exactly what the principal examiner reports reveal about this high-stakes topic. It helps us understand why drawing conclusions about homologous pairs is historically so tough for candidates. The examiners highlight 3 specific warnings, and honestly, this proves that generic, surface-level revision just fails. Examiners are literally telling us that answers are way too vague and lack specific details. On top of that, students constantly forget to check their units and terminology, and their answers aren't specific to the context of the question. This shows exactly where you're losing points when that exam clock is ticking. You can't just memorize facts, you absolutely have to apply them precisely. Now, what's really interesting here is the official examiner alert, which explicitly states that candidates consistently confuse key terminology. So when you're writing an extended response about homologous pairs of chromosomes, defining your terms clearly right at the very start is your first mandatory quick win. It firmly anchors your answer and immediately shows the examiner you understand the core principles. And that brings us to this brilliant point. The whole theoretical architecture of this topic rests on integration with other syllabus areas. The examiner reports are practically shouting this at us. Isolated study will cost you the top band. You really have to understand the causal relationships and exactly how homologous chromosomes connect to the wider biological concepts across the entire 9700 syllabus. All right, moving right along to Section 2, the technical methodology. So the crucial takeaway here is shifting your mindset from just knowing biology facts to actively applying a systematic method. Examiners actually award marks for your systematic processing, even if your final answer has an error. But to get those marks, you need a procedural framework. In just a moment, I'll share a hidden examiner clue regarding alternative interpretations that will completely change how you write your analytical answers. But first, we need to build the framework that makes that clue super obvious. If you miss this, you'll be missing the very thing that separates an A from a B. Whenever you're tackling examination questions on 16.1, you absolutely must rigorously follow the standardized 5-step sequence. First up, deconstruct the question and identify the key elements. Second, apply the relevant analytical framework. Third, execute your analysis with clear working and notation. Fourth, verify your results. And finally, fifth, present everything using the correct terminology. Following this exact sequence guarantees you lock in those critical method marks every single time. Now, let's think about how this applies across different domains. Whether you're interpreting complex data or evaluating practical work, your skills need to be razor sharp. For data interpretation, you must extract evidence, interpret relationships, and calculate relevant statistics. On the practical side, it's all about selecting the right apparatus, making accurate observations, and identifying anomalies. In both scenarios, the ultimate goal is the same: drawing hard, evidence-based conclusions directly from the stimulus materials provided in the exam. Let's step it up a notch with Section 3, Advanced Critical Analysis. We're escalating the stakes here because higher-order assessment objectives demand that you don't just describe things. You actually have to evaluate alternatives and heavily justify your conclusions. Remember that cold open mistake we talked about at the beginning? Well, here's the solution. Comparative analysis requires you to systematically identify similarities and differences. You've got to utilize explicit comparative connectives, words like whereas, however, or in contrast. Furthermore, every single point of contrast needs to be supported with hard evidence from the data, which then allows you to draw conclusions about their relative importance. And here is that hidden examiner clue I promised you earlier. To achieve those top evaluative levels, you must explicitly evaluate the quality of the evidence itself. This means identifying limitations in the method, acknowledging any assumptions that were made, providing alternative interpretations of the results, and crucially, linking all of that directly to how it impacts the final conclusion. This right here is exactly what examiners are frantically searching for when grading a top-tier paper. Okay, let's put all of this to the test in Section 4, the Interactive Viewer Exam Challenge. Let's do a Cambridge-style interactive challenge. I want you to pause for a quick second and predict exactly why the flawed answer on the left loses marks. Do you see how it's super vague, lacks specific data extraction, and has literally no logical sequence? Now look at the other side and try to spot the structural elements making it a top-band answer. It defines the terms right out of the gate, extracts specific stimulus data, connects straight back to core biological principles, and uses precise terminology. It's night and day, right? Here's your examiner-style correction. That improved answer succeeds entirely because it follows this exact, unbreakable architectural flow. You start with the core concept, then you immediately back it up with evidence or data extracted right from the question. Next, you apply your scientific reasoning, and you finish strong by using precise examiner wording. Seriously, if you memorize this 4-step flow, your answers will practically grade themselves. Which brings us nicely to Section 5, the final grade strategy. Let's quickly recap the core strategy we've built up today, right before we uncover the one hidden trap that could still absolutely derail your exam performance. It all boils down to 3 key takeaways. First, always. Always be specific to the context given in the stimulus. Vague definitions just won't survive. Second, rigorously apply that 5-step standardized sequence for processing data and practicals to secure your method marks. And third, structure your critical analysis using that unbreakable concept to evidence to reasoning to wording framework. But here is the ultimate diagnostic cliffhanger for you. You can memorize everything we just talked about. You can execute this entire framework perfectly and still score a flat 0. Crazy, right? How does that happen? Well, it happens if you misinterpret the specific command words that dictate the mark band. If an examiner says evaluate and you only describe, all the frameworks in the world won't save you. So, to decode those exact command words and ensure you never lose those massive marks, watching our next explainer is your absolute mandatory next step. We're going to break down exactly what each command word demands from you. Make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGSC to excel in your Cambridge examinations. Because honestly, what good is a perfect answer if it's to the wrong question? Think about it. See you in the next masterclass.